Alright, welcome back. We are heading into chapter 4 talking about discrete random variables. So this is where we're really going to start to kind of head in the direction that we're going to be going for most of the rest of the semester. Dealing with random variables, looking at probabilities of events occurring, things like that. So to set us up here, we're just going to define what a random variable is. So a random variable describes the outcomes of a statistical experiment in words. The values of a random variable can vary with each repetition of an experiment. So random variables are denoted using letters such as capital X. And a random variable is said to be a discrete random variable if it has either a finite or countable number of values. So remember, discrete means finite or countable. As you know, if we're counting 1, 2, 3, 4, 5 times, this thing could happen. So random variable is just describing the different possible outcomes in any type of statistical experiment. And it's said to be discrete if it can only happen like a countable number of times. So notationally, if big X is a random variable, then big X is written in words and little x is given as a number. So little x tells us what the actual possible values are that could occur. So like in this example, if big X is the number of heads when tossing 3 fair coins, the sample space, S, is all possible ways you could toss 3 fair coins. Right? You could get tails, 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 heads, 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 tails, heads, etc., 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 all the way up to heads, heads, heads. And when we talk about the number of heads when tossing 3 fair coins, well, the number of possibilities, X could be 0 heads, 1 head, 2 heads, or 3 heads. Those are the only possible outcomes, right? You can either toss 0, 1, 2, or 3 heads if you're tossing 3 coins. Okay, so this is kind of the distinction between, if you're wondering later on what is the capital X versus the little x. Capital X is the random variable. It's the description of what is actually happening in the experiment, and little x gives us the potential values of the random variable. So into section 4.1, probability distribution function, or PDF, for a discrete random variable. So a probability distribution provides the possible values of a random variable x and their corresponding probabilities. It can be given using a table, a graph, or a mathematical formula. So there's a couple things for a probability distribution we need to remember about probabilities in general. So if p of x is the probability that the random variable x equals little x, okay, so what's the probability that this event will happen this many times? That's basically what that is saying. We need to remember a couple things. That the sum of all the probabilities is 1. Okay? If we're having an event occur, something's going to happen, right? One of our potential outcomes is going to happen, right? So if we were looking at flipping a coin, getting heads or tails, the probability that I get either heads or tails is 100%, right? It's a value of 1, right? Similarly, like if I roll a die, right, I get probability that I roll a 1, 2, 3, 4, 5, or 6 is 1, right? Because there's a 100% chance that that will occur. And all values of probabilities must be between 0 and 1, with 0 representing an event that will never occur, and 1 being an event that will definitely, certainly occur. Okay, so all probability values lie within that region of 0 to 1. So determine whether the given table is a probability distribution. So for the first one here, so let's look at each of these values. So here's all the possible outcomes, right? We could have whatever scenario this is. It could have 1, 2, 3, 4, or 5, and the probability that each of those occurs is given over here. So first thing to check, just really quick, do we have any negatives? Because that would rule us out immediately. Probabilities have to be between 0 and 1. Okay, so no negatives. Any values bigger than 1? No. So we're good on that front as well. Now the question is, do all the probabilities add up to 1? And it turns out if you add these numbers up, they don't. We get actually 0.97. So we've left off 0.03. right? So there's a probability that something else could occur that's not in our list here. So that's not a valid probability distribution. So this one is not. For the second one, if we look, again, remember that second qualification, all probability values must be between 0 and 1. We get an immediate disqualification right there. We cannot have a probability of negative 0.01. So this one is also not a valid probability distribution. Now if we look at the last one, we have all the values between 0 and 1, so that's a good sign. And if you add up all of these values, you will find that you do get 1.00. So this one, we say yes, it is a valid probability distribution. Okay, because it satisfies these two conditions, that the sum of all the probabilities is 1, and that each one individually is between 0 and 1. Okay, so let's look at an example. So the table below shows the probability distribution for the random variable x, where x represents the number of movies streamed on Netflix each month. What is the probability of streaming at least 3 movies each month? What is the probability of streaming less than 3 movies each month? Okay, so for this probability distribution, we're looking at the probability that our random variable is bigger than or equal to 3. Right? That's the probability of the number of movies being watched being at least 3. Okay, so this is our symbolic way of writing that statement. So that's going to be everything 3 or more. So that's going to be 0.10 plus 0.03 plus 0.01. So that's 0.14. So there's a probability of 0.14 that a randomly chosen household, right, would watch at least 3 movies each month. Okay, so fairly low. And then the probability that they watch less than 3, so the probability that our random variable is less than 3, is going to be everything up here. So that's going to be 0.06 plus 0.58 plus 0.22, which is 0.86. So the probability that they watch less than 3 movies each month is 0.86, so that seems highly likely. Or you could have also solved this just noting that these two events are complements of each other. Right? So we have greater than or equal to 3 or less than 3. Those two things are complements. So we could just take 1 minus the probability that x is at least 3. So 1 minus 0.14, which is 0.86. Just another way of getting to the same thing. Okay? So more than one way to argue kind of that probability, okay, using what we know about how to find those probabilities. Okay? And that brings us to the end of section 4.1. Just a quick start off to this chapter.